And let me share my screen. And so, oh, this is not you guys. What am I doing? This is you guys. And so today we're going to look more at permutations and introduce the idea of combinations. Homework 6 is due by the end of today. That's that counting principle that we did on Wednesday. Homework 7 is permutations, which we started on Friday, but we did not finish. Homework 8 is combinations. We'll see how far we get with that. There will be a quiz over the weekend on counting, and by counting, I mean the fundamental counting principle, permutations, and combinations. The general idea of the questions are, in how many ways can this occur, or evaluate this permutation, or evaluate this combination. Hopefully everybody has their calculator with them, because again, those calculators make those permutations, combinations, and factorials a lot less work to do. Before we get started with the new material, let me pull up the my labs. Does anybody want to look at any homework questions or anything in general?
No.
Okay, and also in terms of the tests that I graded over the weekend, does everybody know how in Blackboard, if you look in the grade book, if you clicked on an assignment, there should be something that comes down with like a dot that says when your attempt was. And if you click on that, you can see the annotated paper, the paper that I graded, the paper that I marked things right or wrong and wrote comments on. So if you want to see, what was what, that would be where you'd go to look. A lot of people, I wasn't able to really make that much annotation because a lot of people didn't put anything down, pencil and paper, for a lot of the questions. And if I don't see any work, I can't justify giving partial credit. And so try to get into the habit of maybe writing a little bit more than you might think you want to write, just because that opens that window of partial credit a little bit further. That having been said, if there are no questions, let's look a little bit more at permutations. Just a real quick refresher from when last we met. We had said that permutations.
You said the quiz is going to be on all the three above?
Yes.
Okay.
And we'll talk through it on Friday. Okay.
Okay, sounds good.
You didn't open the quiz yet, right?
No, it won't be available until after class time Friday.
Okay.
So permutations, and I made this executive decision to not have the quiz open before class times, that people don't ask questions about what was in the quiz before other people started taking it. So permutations are arrangements. We said that the objects have to be distinct, each different. You can't repeat, and order matters. And so let's say, for example, I want to know how many 3-digit numbers can be formed if digits cannot be repeated. So because digits cannot be repeated, and our digits 0 through 9 are all different, we've got to decide, does order matter? When I make a 3-digit number, does the order in which I put those digits in make a difference?
Yes, because order matters, right?
Right, yes, because order matters. And so we've got 10 digits to choose from. Order matters, and we want 3. So 10p3 you can get from your calculator. Or again, if you're doing it by hand, it says I want the first 3 digits of 10 factorial. Either way, you get something like 720.
How is that a 3-digit number? I don't understand that part.
Okay, what the question is saying is I can use any of the digits 0 through 9, and I want to come up with a 3-digit number. So it could be like 987, it could be 986, it could be 874. I'm saying, what's the total number of digits, that 3-digit numbers that I can come up from? 10 says how many digits I have to choose from. There's 10 digits. And 3 says how many I'm using.
So will it always be 10 to pick from, or?
With digits, unless it says, excluding 0, or unless, it depends on what we're looking at. If I asked how many 3-digit numbers can be formed from, let's say, the numbers 1 through 5, then there's only 5 to pick from. But I'm still picking 3 digits.
So it's always going to be 3?
If it asks for a 3-digit number, instead, if I asked for a 2-digit number.
Now, if we pick 3-digit number, we wouldn't all have the same answer, right?
No, I'm asking how many are possible. I'm not asking you to give me that 3-digit number. I'm asking if you were to write all of the possible 3-digit numbers you can come up with, how many would there be? So if I ask all of the possible 2-digit numbers from 1, 2, 3, 4, 5, there's 5 digits to pick from, and I want to pick 2. So 5 permutation 2 tells me there's 20 different 2-digit numbers that I could make from those digits. 54, 53, 52, 51, 45, 43, 42, 41, 35, 34, 32, 31, 25, 24, 23, 21, 12, 13, 14, 15. There would be 20 different possible numbers. Any better?
Kind of, but could we maybe go over the calculator rules again, or do we not have time?
In order to get this on your calculator, to get this answer on your calculator, if you have the TI 30, you're going to type the number 5, then you're going to type PRB, and then you're going to make sure that NPR is highlighted. Then you're going to probably type 2, and then you're going to type equal. If you have a graphing calculator, you're going to type 5, then you're going to go to math, then you're going to go to PRB, then you're going to highlight NPR, then you're going to hit 2 and equal. So this is for the TI 30, this is for the graphing TI. If you have a different calculator, a different model, I'd have to look at your calculator to see just where to go.
Thank you.
So can you get that 20 from 5P2? And can you get that 720 from 10P3?
Yeah.
Okay. And again, we're using permutations if order matters, and the objects have to be different and they can't repeat. But there's one special case that we will look at, and it's going to be permutations with repeats. And so let's look at some examples first. Let's say, how many ways can I arrange the 3 letters in the word CAT? Well, when I'm rearranging the letters, order matters, so it'll be a permutation. There are 3 letters to pick from, and I want to use all of them. And 3p3 would be the same when we're using all of them. It's 3 factorial. So you can either use your calculator for 3p3 or 3 factorial, or by hand, you can multiply 3, 2, 1 to get 6. And since there's only 6, let's go through and list the 6 ways. I'll do the hard one, CAT. Can anybody think of another way I could arrange those letters?
TAC.
TAC, great. Another one?
ACT.
ACT, great. Is there another one we can do where C is first?
CTA.
Beautiful. Is there another one with T first?
So the words don't have to make sense.
No, they don't have to.
All
make
up. Okay.
TCA and ATC. And so we've got all 6 of them. Now, what if instead I want to make 3-letter, and we'll put words in parentheses, but again, they don't have to make sense, from the letters in the word ALL. And you see, this kind of violates that idea of a basic permutation because 2 of them are the same. If we tried to list them, I'll do the hard one, ALL. What would be another one?
LAL.
Any more?
LLA.
LLA. And I think that's it. And so do you notice if there's repeats, there are fewer? And the way we get the fewer is by division. We're going to have a rule that says that the number of arrangements of n letters, so n will be the total number that I have if R repeat, S repeat, T repeat, and I'm going to put ... because there could possibly be more than 3 different letters that repeat. Or and actually that shouldn't be letters, I apologize, that should be objects. Is n factorial over R factorial, S factorial, T factorial.
Why those? Why RST? Where did that come from?
Give me a minute and I'll clarify, okay?
Yep.
Let's first apply this to all. For all, there are 3 letters. And is everybody all right? 2 repeat, so it would be 3 factorial over 2 factorial. So that would be 3, 2, 1 over 2, 1, which gives me my 3. But now, why RST and all that other garbage in there? Let's see how many different ways can we arrange the letters in, you ready? Mississippi, Mississippi. Well, what's the total number of letters in the word Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But do some letters repeat?
Yeah.
What repeats?
The I and the S and the P.
ISP. And for the I, there are 4 of them. So I need a 4 factorial for the I's. For the S, there are 4 of them. So I need a 4 factorial for the S's. And for the P, there are 2 of them. So I need a 2 factorial for the P's. And you see, I need a separate factorial for each thing that repeats. And that's what the RST is all about. If you've got multiple things that repeat, you need a different factorial for each of them. Any better?
Yeah.
Be careful when you do this with your calculator. With a calculator, what you have to remember, whenever you have a fraction with work going on in the numerator and denominator, is you need to type parentheses around that part. So we'd have to type parentheses around the denominator. So let's do this first by hand. 11 factorial is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 4 factorial is 4, 3, 2, 1. 4 factorial is 4, 3, 2, 1. 2 factorial is 2, 1. And you see, when I start dividing things out, there wouldn't be all that much left. Calculator, you'd have to type in 11, go to that probability menu and pick the factorial. And then to get the slash for the fraction, I use the division sign. But again, this is where it's real important that we put parentheses around the denominator. And then we'll put
Where
in
did we, excuse me, where did we get the little exclamation after the 11?
the factorial. Again, remember, if you've got that TI 30, you're
Mhm.
going to first type 11, then you're going to press probability,
Okay.
and then you're going to arrow over to the exclamation point, the factorial. Do you see it now?
Yep, I see you.
Okay, then we'll go 4 factorial, 4 factorial, 2 factorial, and then you have to close your parentheses and hit equals. And so how many different ways can we arrange the letters in the word Mississippi?
34,650.
34,650. Should we start listing them? I don't. I think there's too many, but I want everybody to try it without the parentheses. If you type that in without the parentheses, you get a much bigger number, don't you? Don't you get something like 79,833,600? The
Yeah.
reason is if I did it without the parentheses, 11 factorial divided by 4 factorial, this is all that I would divide. And then I'd end up multiplying it by the other 2 numbers, which is not what I want. And so you have to remember, when you're doing this, you've got to type those parentheses around your denominator. So let's look at another example. Let's say I have 8 beads. In my 8 beads, there are 2 red, there are 2 white, there are 4 blue. How many different ways can I string them? many are there altogether?
8.
8. So if they were all different, it would be 8 factorial. But they're not all different, are they? Some are the same. What's the same?
2 red,
Anything else?
2 white,
Anything else?
4 blue.
And so, again, remember, if you're using a calculator to evaluate this, you've got to type those parentheses around the denominator. I'm going to be old school and do this one by hand. So I'm getting 420. Calculator people, are you also getting 420?
Yes.
And let's look at one more. Let's look at the arrangements of the letters in, let's say, happy. And this time I'm going to shut up and ask you guys to do this. Did anybody else get 60?
Yeah.
So do you see the need for the dividing out into different factorial for each separate thing that repeats? And you've got more than one thing that repeats, you've got to put parentheses around that denominator, okay? If that's all right, that's the end of permutations. That was what we didn't get to last class, permutations with repetition. Next, we're going to look at combinations. And combinations give me the number of arrangements of, and just like with permutations, your objects have to be different, distinct objects. Just like with most permutations, we don't want to repeat. But what's different with combinations is that order does not matter. Now, here's silly math geek talking. Does anybody have a combination lock?
Yes.
When you put your numbers in the combination lock, the order matters, doesn't it?
Yeah, it does.
So shouldn't they be called permutation locks and not combination locks? Oh, somebody messed up somewhere along the line. Permutations order matter, combinations, it doesn't. We're going to define NCR is going to be the number of combinations if we pick our objects from n choices, and NCR, there's a couple of different definitions. The definition that I learned in pre-calculator days was it was the permutation divided by the small number factorial. If you use Help Me Solve This in Mr. Blitzer's book, he'll have that as n factorial over r factorial n minus r factorial. Again, If you're using a calculator, you don't really need either of those definitions. If you're using a calculator, you're going to press the first number. Then you're going to go to wherever that probability menu is, and you're going to enter over till you get to NCR, which I don't know if you noticed, that's in between your NPR and your exclamation point. Then you're going to type in that second number. So let's look at, for example, if I have 5 combination 2. By hand, I'm going to look at that as 5 permutation 2 over 2 factorial. By hand, my denominator is 2 times 1. So I'm going to take 2 factors starting with 5, and that'll divide out to 10. Mr. Blitzer's definition, that's 5 factorial over 2 factorial, 5 minus 2 factorial, which would be 5 factorial over 2 factorial, and then 5 minus 2 is 3 over 3 factorial, and that takes me to the same place. With a calculator, you'll type in 5, you'll go to that probability menu, you'll arrow over to NCR, type in 2, and hit equals. And that should also get you to 10. So let's say from a class of 16, how many ways can I select 3 students to work together? And if they're working together, if you're in a group of 3 people doing something together, it doesn't matter to you whether you were the first one picked or the last one picked. You're all in there together working equally. So 16, order doesn't matter, combination 3. And so could everybody please, with your calculator, look at 16 combination 3.
$560.
Yeah,
500.
but I just got doing it by hand because I'm the geek who does it by hand. But yeah, with the calculator, is everybody getting 560?
I did.
Great. Now I'd like to open another page to show you something that I think is interesting. Mr. Blitzer doesn't really talk about it, but on the off chance that you have to do a combination by hand without a calculator, I'd like everybody to take a minute and for me find each of, oh, I'm sorry, I lied. I've got to go back for a minute. There's one exception to the rule. Any number combination 0 is 1. And how many ways can I pick on nobody? Well, there's only one way of doing nothing. Any number combination 0 will always equal 1. I apologize for forgetting that on the previous page. So find each of the combinations of, let's say, 6. So I want 6 combination 0, 6 combination 1, 6 combination 2, 6 combination 3, 6 combination 4, 6 combination 5, 6 combination 6. And I'm going to give you folks a minute to figure those out, either by hand or by calculator, and tell me what you get. For 6 combination 0, did you get 1? 6
Yeah.
combination
Yeah.
1, 6. 6 combination 2, 15. 6 combination 3, 20. 6 combination 4, 15. 6 combination 5, 6. 6 combination 6, 1. Did you guys get those?
Yeah.
Did you
Yes.
notice anything interesting?
They kind of go back to where they started.
Don't
That
they
one.
repeat? Aren't some of them equal?
Yeah.
And so if I look at 6 combination 0, it's equal to 6 combination 6. 6 combination 1 is equal to 6 combination 5. 6 combination 2 is equal to 6 combination 4. For them to be equal, they're all different combinations of 6. But I want you to look at those second numbers. 0 and 6, 1 and 5, 4 and 2. Don't those second numbers, when I put them together, don't they add up to 6?
Yeah.
So I'm going to be able to say that n combination r is equal to n combination n minus r, which is interesting. But where it would become useful is, let's say, for example, I want you to find 100 combination 98. I'm looking at doing that by hand. I would need to start finding 98 factors, which would be, I don't want to do that by hand. Does anybody want to do that by hand? Multiply out 98 numbers?
No.
So using this rule, that's going to be the same as 100 combination. Well, what's 100 minus 98? 2. And now that's real doable because I'm only taking 2 factors and dividing it by 2 factorial. And so going through and doing it by hand, that would give me 4950. Again, if you're doing it by calculator, go ahead and do that 100 combination 98 and it'll give you the answer. I'm just saying, if you don't have your calculator and you're doing it by hand, sometimes if you subtract, it gives you a much easier computation. And so basically factorials, permutations, combinations, if you don't have a calculator, you've got to do the number crunching by hand. If you do have a calculator, it's just remembering where to find the functions in their probability menu. The difficulty that some people end up with is, how do we know if it's a P or a C? Rule is P, order matters. C, order does not matter. And with each of them, the objects have to be distinct, different, and there's no repeating. And so I took the liberty of uploading to the notes 2 pages from the virtual textbook at in the combination section. Just want to look at the if you folks with my help can identify, is it a permutation or a combination or even just the counting principle. So if everybody's got this down, can I pull up that page from the book? There's actually 2 pages.
Yeah.
Okay, first page. It says, in 1 through 4, does the problem involve permutations or combinations? It's not necessary to solve it. But let's go through and let's write it out. Question 1 says a medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? So you're one of those 13 people that volunteered. Does it matter to you when they're picking 6 names out of a hat, whether your name came first or last, or does it just matter whether you're included in the group?
Just matters if you're included.
So is everybody all right that with this one, order does not matter? So it would be a combination, and we would take 13 combination 6, 13 people, and we're choosing 6. Question number 2 says 50 people purchase raffle tickets. 3 winning tickets are selected. First prize, and I have to apologize, this watermark comes whenever you print a page from the virtual textbook because they want credit. First prize is $1,000. Second prize is $500. Third prize is $100. How many different ways can prizes be awarded? Well, would it make a difference to you whether you got the first, second, or third prize?
Yeah.
Yes. I want the $1,000, not the 100. So order matters. It's a permutation. There's 50 people, and we're picking 3. Three, how many different 4-letter passcodes can be formed from the letters A, B, C, D, E, F, and G if no repetition is allowed? Well, like a passcode is like a password, right? When you type in your password, does the order in which you enter the letters matter?
Yeah.
Yeah. So order matters. It's a permutation. How many do we have to pick from? 1, 2, 3, 4, 5, 6, 7. And how many are we picking?
4.
4. And then let's look at number 4. It says 50 people purchase raffle tickets. 3 winning tickets are selected at random. Each has a prize of $500. How many different ways can the prizes be awarded? If the 3 prizes are the same, does it matter to you whether you're first, second, or third?
No.
No.
So is everybody all right? This would be a combination.
Yes.
Combination 3. And so do you see how you have to think about it in deciding whether order matters or not?
Yeah.
Then next column says, whoops, evaluate each expression. Applications, the directions for this one tells you to just use combinations. And somehow that whole page didn't come in there. That's really ugly. Those, do you see how the paragraph got cut off in the middle? So let's just go on to that second page. And this one is not cut off. And so here, the directions say you have to decide whether it's a permutation or a combination and do the correct one. 43 was like the first one we did. 44 we looked at already. Let's look at 45. From a club of 20 people, in how many ways can a group of 3 members be selected to attend conference.
Combination?
Combination, because we don't care whether we were the first or the last person going. We just want to know if we're going or not. So that would be 20 combination 3. I think we looked at the content of 46 already. I think we looked at 47 already. Let's look at 48. 9 comedy acts will perform over 2 evenings. 5 of the acts will perform on the first evening. In how many ways can the schedule for the first evening be made? Well, when we're making a schedule, are we concerned with who performs first and who performs last?
Yeah.
Yeah. And so here, order matters. How many do we have to pick from?
9.
9. And for the first evening, we're picking 5. Let's scooch down to 51. 51 says a restaurant lunch special allows the customers to choose 2 vegetables from the list of okra, corn, peas, carrots, and squash. How many outcomes are possible if the customer chooses 2 different vegetables? Well, when you're making your choice, if you want okra and corn, is it any different than if you want corn and okra?
No.
No. Does order matter?
No.
So this is a combination, and there's 1, 2, 3, 4, 5 to pick from, and we want to pick 2. Now I want to skip down to 53. 53 says you have 3 dress shirts, 2 ties, and 2 jackets. You need to pick 1 dress shirt, 1 tie, and 1 jacket to wear to work today. How many outcomes are possible? This one's a little different, isn't it?
Yeah.
Yeah. This doesn't seem like the permutation and combination questions, does it? Doesn't this seem like my counting principle?
Mm-hmm.
And so you have to be careful. Every once in a while, you're not going to have a permutation or a combination, but rather you're going to have a counting principle. We've got 3 things to pick. We have to make 3 choices. We have to pick a shirt. There are 3 to choose from. We have to pick a tie. There are 2 to choose from. We have to pick a jacket. There are 2 to choose from. The word and tells me I'm going to multiply, and so there will be 12 different outfits.
How can we tell them apart? Like from accounting, then
Well, over here, we're making 3 different decisions. Over here, we're just making 1 decision, vegetable, and we've got 2 to pick from. Over here, we're making 3 different decisions. Does that help at all? And then there are some, like question number 56, that's both, that's a B, counting. And let's see. It says in the math department, there are 4 female professors and 6 male professors. 3 female professors will be chosen to serve as mentors for a special program designed to encourage female students to pursue. I apologize, I picked the wrong question. This isn't both. To encourage female students to pursue careers in mathematics. How many ways can they be chosen? Well, here, if we're going to be in the a mentor, we're either in the group or not, so it's a combination. There are 4 women to choose from, and we only need 3. I apologize. I had thought that question 56 was more like 57. Let's look at 57. 57 says there are 4 Democrats and 5 Republicans on a county commission. From among their group, they will choose a committee of 2 Democrats and 2 Republicans to examine a proposal to purchase land for a new county park. How many 4-person groups are possible? Hey, I'm gonna, I know you guys don't want to hear me sing, but sometimes I spend too many years as a stay-at-home mom, and every once in a while, some of these questions bring back visions of watching Sesame Street with my children. Does anybody remember Cookie Monster? C is for cookie and it's good enough for me. Well, C is for combinations. C is for committees. C is for cards. Usually if it's a committee, it's a combination. Usually if it's a card problem, it's a combination. So just a little memory aid that I have. So we have combinations. But do you notice I need a combination for the Democrats? I need a combination for the Republicans. I have 2 decisions to make. I have 4 Democrats and I want to choose 2. So that's my Dems. I have 5 Republicans and I want to choose 2. Those are my Republicans. In between that word "and" is where the counting principle tells me to multiply. And so this one, we've got both combinations and the counting principle. Interesting?
Yeah.
And then I want to look at the bottom at 59. A group of campers is going to occupy 5 campsites at the campground. There are 12 campsites to choose from. So, okay, all right, we're picking 5 out of 12. So there's 12 and I'm going to pick 5. I've got to decide does order matter or not? So have any of you guys ever gone camping?
Yes.
Yeah.
When you go camping, does it make a difference to you which site you have, where you are? Does it make a difference to you whether you're next to the bathroom or whether you're next to the dumpster or whether you're next to loud people or whether you're next to quiet people?
Yeah.
Yeah. And so that's like saying order matters because the campsites are different. And so this one's going to be a permutation. Does that make sense? It's kind of like when we were saying we were the director last class and we were picking people for 2 different roles. Because the roles were different, order made a difference. It made a difference to us which role we got. Over here, because the campsites are different, order
What's-
matters. Makes a
What's the
difference.
answer on this?
So 12 permutation 5 is, I'm going to use my calculator and not try to do it by hand if you don't mind.
Is the 95,040?
12 permutation
95040?
Yeah. 95040. So I don't want to be the director of this group picking who camps.
Mhm.
Too many different ways. Right? Yeah,
Yeah.
that's a number, isn't it?
That's a big number.
Yeah. So, but I digress. Does going through these kind of give you a little bit of a feel as to how to decide whether you think order matters or not?
Yeah.
Okay. And so I'd like to, initially I had inserted another page as if we were going to start talking about the definition of probability, and we're not. Going to stop here for today. And the quiz over the weekend will be, okay, here are these questions. Am I going to use the counting principle? Am I going to use permutations? Am I going to use combinations? Is it a permutation with repeats? And what's my final answer? Okay. And again, we'll go over those concepts a little bit more on Friday before we look at that definition of permutation. I'm going to stop sharing my screen, stop recording.